Hi everyone. Today we'll be working on solving systems of equations, but we'll be talking about a quadratic linear system. So when solving a quadratic linear system, you're solving for the point of intersection between the quadratic, the parabola, and the line. So here are three different scenarios that could possibly occur. In this first example right up here, we could have two intersection points between the line and the parabola. So on this line below, I'd like you to write two solutions. All right, that's one scenario. The second scenario could exist where I have a parabola and a line, but they meet at a point that's tangent, meaning it only goes through once, it doesn't hit twice. So in this case, there's one solution. And the third and final case would be where they don't intersect at all. The parabola and the line never meet, so that would be zero solutions. All right, this is a little bit different than solving linear systems of equations because now we're going to have two different types of equations in our problem. So just recall where it says quadratic equations are in the form. I want you to write y equals ax squared plus bx plus c. This should be familiar to you. All quadratic equations would be in this form, and all lines are in the form y equals mx plus b. It's important to know what you're doing, not just go through the motions. So looking at this first example, it says solve the following systems algebraically. So like we discussed, when we're solving a system algebraically, we're solving for the point or points of intersection. So when we're done solving this, we could either have two solutions, one solution, or no solutions. So this is kind of similar to when we had two linear systems. You see how this says y equals something and y equals something else? What method do you think we would use to solve it? Well, we would actually set them equal to each other. Because if y equals this and y equals this, I could say this piece equals this piece. So I'm going to put 3x minus 6 equals x squared minus x minus 6. So what we're doing is we want to find where the line mx plus b is equal to the quadratic ax squared plus bx plus c. So this is your quadratic, that's your line. So we want to know where these two things are equal, or in other words, where they intersect. So this is now just solving an algebra problem. You should remember from algebra that when we have an x squared, we're probably going to have to do some factoring. So we want to get it equal to 0. So we want to move this 3x and this negative 6 to this side over here. So let's start by doing that. Let's subtract the 3x and let's add the 6. So subtract the 3x and add the 6. I'm going to do this in one step. So those two will cancel. I'd be left with the 0 equals x squared. Now what is a negative 1? Negative 1 minus 3x, you should be saying is negative 4x. And what happens over here when I do negative 6 plus 6? You should tell me 0. So those actually cancel as well. Alright, so like I said before, we're probably going to have to do some factoring. So now the first step of factoring is always to check for a GCF. Is there a number or letter in common between the x squared and the negative 4x? You should be telling me x. So remember, when we write a GCF, we write the GCF followed by an open parenthesis. Now we do x squared divided by x. You should be saying x. Negative 4x divided by x. You should be saying negative 4. And this is still equal to 0. So now that we factored, every time that there's a break in the parenthesis, we're going to do a t-chart. And we're going to set each of these pieces, this piece and this piece, equal to 0. So this is x equals 0. This is x minus 4 equals 0. Add 4. X equals 4. So what you just solved for are the x values of the point of intersection. So I mean, if we want to just have a sketch of this and see what it looks like, I'll just do it in the corner. We've got a parabola, and we've got some line going through it. So we've got this point right here of intersection and this point right here. So those points are x, comma, y, right? And you just found the two x values of the points of intersection. So we could put 0 for one of them, and we could put 4 for one of them. So in order to finish the problem, you need to find the corresponding y values. So just like we did with linear systems, we can go ahead and plug into any one of these two equations that we want to find y. But this time we're going to have to do it twice because we have two x values. So let's pick the line. The line's easier. So I'm going to write that over here. Y equals 3x minus 6. And I'm going to first plug in this 0 over here. So y equals 3 times 0 minus 6. You should get, when you put that into the calculator, y equals negative 6. So what you just found is the corresponding y value when the substituted x value was 0. So if you wanted to go up here, you could say y is 0, negative 6. So what we want to do is write it as a point once we've finished it. That is one solution. Now you must be saying, well, I need to find the other solution. I have the x value of 4. I need to find the y value. So we can use the same equation that we used up here before. So let's write it again. Y equals 3x minus 6. And now this time, we're going to substitute the 4. So y equals, and you could put this whole thing into the calculator. You should get 6. So this 6 goes right up here. And now, my other point of intersection would be 4, 6. And you'd be finished. Now, what I want you to do right now is pause the video, and I want you to type this into the y equals, and put this one into the y equals as well, and use one of the two techniques that we taught you to solve and check with your calculator. Either use the table, or get a picture like this and hit second trace 5 for intersect and see if you get these 2 points. If you get it, you did the problem right. Okay, I think we're ready for a second example. Here is example number 2. It looks a little different than the first one because they're both not y equals. So you should have first recognized that this equation down here is the quadratic because it's got the x squared, and this one's the line. We could set this quadratic and get it into y equals. We could get this line, set it into y equals, and then set them equal to each other. That's one option. The other option would be to solve this top equation for y. So let's write that on the side over here. We've got 5 equals y minus x. Let's solve for y. Do you agree it would be y equals x plus 5? So all I did was just manipulate this line into this form. Now if y equals this stuff, I technically can substitute x plus 5 for this y right here. So this is that other method that we talked about called substitution. So we could do that if we want to. So I think I'm going to do it that way. If you feel that you want to try it by setting them both equal to y and then setting them equal to each other, I challenge you to do it and see if you get the same answer as me. So what I'm going to do is I'm going to take this y of equaling x plus 5 and I'm going to substitute it into that one. So I've got 4x squared equals negative 17x plus x plus 5 plus 4. Now, I didn't use parentheses when I substituted because I've got a plus sign in the middle. There'll be no distributing of negative 1. It's just not necessary. Okay, so do I have any like terms on this right-hand side over here? I have a 5 and a 4, which add to 9, and a negative 17x and a plus 1x. So this could be negative 16x plus 9. All I did was add the 5 and the 4 and got this 9, and then I added negative 17x plus 1x and got negative 16x. And I'm just going to bring down the 4x squared. Okay, now just like before, whenever we have an x squared, we have to get everything equal to 0 so that we can possibly factor and solve. So I see the 4x squared here. I don't want to make it negative by bringing it over here. I don't like working with negative coefficients like that. So I'm actually going to bring these two pieces over. And when I bring them over, I'm just basically adding 16x and subtracting 9. So you should have 4x squared plus 16x minus 9 equals 0. Alright, so now I have to factor this quadratic. There's unfortunately no GCF that I can take out. So GCF is out. I could, if I wanted to, use the quadratic formula to solve this, Or I could just factor I use earmuff. If you have Miss Atori or Miss Barris, they probably do guess and test. So we're going to multiply the 4 times negative 9, and we'll get negative 36x squared. And we want to find the factors of negative 36x squared that add to 16x. So pause the video, take a minute, see if you can find those factors, and then hit resume. Okay, so you should have gotten, bring down the 4x squared, bring down the 9, you should have gotten plus 18x minus 2x, because 18x times negative 2x multiplies to a negative 36x squared, and 18x minus 2x adds to a 16x. Now we're going to factor by grouping. So group these two and these two. Bring down the negative. So the GCF between 4x squared and 18x is 2x. I'm left with 2x plus 9. Now I want to take the GCF between negative 2x and negative 9. The only thing there is a 1, so we're actually going to take out a negative 1. So now what's negative 2x divided by negative 1? You should be saying 2x. Negative 9 divided by negative 1 is a positive 9. Please don't just bring down this sign. Okay, so now the GCF between these two is 2x plus 9. So I'm going to take 2x plus 9, and what's left over is the 2x minus 1. And this is all still equal to 0 from this equal to 0 up here. So it seems as though I ran out of room, but I need to do a t-chart to find the roots. So I'm going to just bring this up here and finish. So I should have 2x plus 9 and 2x minus 1 equals 0. T-chart, set each piece equal to 0, and solve. So x equals negative 9 over 2, and then x equals 1/2. So just like the problem before, you found the x values of the points of intersection. Now we need to find the corresponding y values. So when we do that, we're going to use one of the original equations. I'm going to choose the line just because it seems easier. So 5 equals y minus x. I'm going to first substitute my negative 9 over 2 for x and find the corresponding y value. So 5 equals y minus negative 9 over 2. This is the same thing as saying 5 equals y plus 9 over 2. And to get y by itself, you just have to subtract 9 over 2 on both sides. You have a calculator, don't freak out. So go ahead and put that in. When you do that, you should be getting 1/2. So if you put it all together for a point, when your x value is negative 9 over 2, your y value is 1/2. So negative 9 over 2, comma, 1/2. That's one solution. Now let's find the other solution. I'm running out of room here. Maybe I'll put it up here. So 5 equals y minus x. Now this time I'm going to substitute the other x value of positive 1/2. Y minus 1/2. And all I'll have to do to get y by itself is add 1/2 to both sides. You put that into the calculator. You should get 11 over 2. And please pause the video at any time. Make sure you're getting the answers that I'm getting. And let's put it all together for a point. So 1/2, comma, 11 over 2. So this other point over here would be 1/2, comma, 11 over 2. And we're done. Okay, let's just try the last example. I'm not going to do the whole thing because I feel like this video is getting a little long. So the question says, find the exact solutions to the following systems of equations. You may not know what that means exact, but I'm going to show you in a minute. So first, let's look at this. We've got y equals this, y equals this. Easy for us. Let's set them equal. So x squared plus 3x plus 2 equals negative 2x plus 1. So we got the x squared here. Let's get everything equal to 0. So let's add 2x and subtract 1. So x squared plus 5x, and 2 minus 1 is a positive 1, equals 0. So you should be thinking, just like we did before, oh, I have to factor this, but are there any numbers that will multiply to 1 that will add to 5? Well, the only factors of 1 are 1 times 1. Is that ever going to add to 5? No, because 1 plus 1 is 2, not 5. So that's not going to work. Oh boy. So that means we need to use the quadratic formula to simplify this. So x equals negative b, right? So let's plug in. Let's see if I can fit this. We should be getting, what goes in for b? We should have 5 for b, a is 1, c is 1, so x equals negative 5 plus or minus radical something over 2. So if you put this into the calculator without the radical, so you'd put in 5 squared minus 4 times 1 times 1, you should be getting 21. So your x values are hidden in here. It's negative 5 plus rad 21 over 2 and negative 5 minus rad 21 over 2. So this will be one of the x values. I guess if we're going to make our solutions, is negative 5 plus rad 21 all over 2, comma, some y value. The other solution would be negative 5 minus rad 21 all over 2, comma, some y value. For purposes of this video, I'm going to stop here and say we just found the two y values, the exact y values, because they're in radical form, not in a decimal. So I'm going to challenge you to see if you can find these corresponding y values. The algebra is a little tough, but I would use this one. Use the line and try to find the y values, and we'll start there tomorrow. All right, good luck.